Hello YouTube! So for my video entry for the Mega Favorite Numbers celebration, I wanted just to start by listing a sequence of primes. The first few of them you might recognize as the famous Fermat primes. Those numbers, of course, are 3, 5, 17, 257, and 65,537. Those primes are interesting in their own right, but this being Mega Favorite Numbers, I need to keep going. Obviously, I'm going to need to do something different because, although it's not yet proven, it is strongly conjectured that these are the only Fermat primes that there are. So the next few numbers I'm going to list they're going to be related to the Fermat numbers, but obviously they won't be exactly those because I want them to be primes. So the next two prime numbers in the list are these very large numbers, both worthy of celebration as a Mega Favorite number. But the next one in the sequence is going to be my Mega Favorite number because it's the largest one that I've actually computed. I'm not going to write it on my board though. I'm not even going to read it in the video here because it's 270 digits long. I will write it in the description, so look for the description to see what my Mega Favorite number is. It's a very large prime. So why have I talked about these primes? Well, these primes happen to come up when I was playing around with the odd perfect number conjecture. Just to remind everybody, a natural number is called perfect if the sum of its proper divisors equals that number. So for example, 6, its proper divisors are 1, 2, and 3, and 1 plus 2 plus 3 is equal to 6. About 50 of these numbers are known. They're all even, so no one has ever found an odd perfect number. And many other YouTubers have done videos about perfect numbers in the past. If you want to go look at their videos as a refresher. So I mentioned no one has ever found an odd perfect number, but then again, no one has ever proven that a perfect number cannot be odd. Now don't get your hopes up. I haven't done either of those things. If I had, I would not be publishing a YouTube video. I would be publishing a paper in a journal somewhere. So what I have done, I think, is kind of interesting, and it's related to these. The next thing I want to do is I want to write out a new sequence of numbers that will be related to this sequence. Okay, so this sequence I'm going to make by just multiplying the first few numbers of the sequence together and raising them all to the appropriate power, the power being however many numbers I have. So first one obviously is just 3. The second one will be 3 times 5 squared, because I have two numbers. That comes out to 225. M3 then is 3 times 5 times 17, that number cubed. And that number turns out to be this number, 16 million and change. So in some regard, these numbers are the ones that are more important. The only reason I said the Mega Favorite number is my Mega Favorite number is one of these primes is because they're primes. Primes are so much cooler. But these numbers are even cooler because as you go further on out, these numbers get arbitrarily close to being perfect. By that, I mean if you sum up their proper divisors and then divide that sum by the number, it'll get really, really close to 1. So for example, If you take the sixth number in this list, whatever it comes out to be, add up the proper divisors and divide by that number. On paper. You get that. You get about 0.99906. So pretty close to 1. If you go further on out, as you can see, the decimals get even closer to 1. 0.99969 for the 7th entry, 0.999897 for the 8th entry. So naturally, the conjecture then would be, if you go all the way on out to infinity, take the limit of the sequence would be the fancy way to phrase it, then these fractions here will be arbitrarily close to 1. You know, as close as you want them to be. I haven't finished proving that. There's still some things I need to do to prove that you actually can get arbitrarily close to 1. But I don't know if anyone else has proven this before either. If someone has proven this before, feel free to point that out in the comments. But I don't think anyone has. Not in my research, I haven't seen that they have. So this has been my entry in the Mega Favorite Numbers. Again, if you want to see what the Mega Favorite number is, look in the description because it's too long to fit on my board. But that number is my favorite because it's helped in this search for a number that can be arbitrarily close to being perfect, which I think is really cool. This has been my entry in the Mega Favorite Numbers. Thanks for watching.